Assalamualaikum. My name is Amirul Akmal bin Zuhaili. My matrix number is DE190203. So I'm a student from section 7, group 43. Right now, my friends and I going to do a video presentation for open loop and closed loop speed control system. Right, so overall, we have 3 activities, but I will cover for activity 1, which is the open loop speed control system. Right, so as we can see, this is the figure or the block diagram for activity 1. And we have input voltage, we have electrical part, mechanical part, we have brake, we have torque constant, and this big part is called as a DC motor. And then we have tachometer constant at the end of this system, right? So before we can run the simulation, we need to ensure that all the value has been set, right? So for input voltage, we set it to 240 volts, and for the parameter values of the DC motor, we set it accordingly to the table, and the tachometer constant we set it to 0.065, right? And then I place the 4 scope here, which is to generate the waveform. Then the simulation time is 10 seconds. Alright, so without further ado, let's have a look on the first waveform. Alright, so this is the waveform of input voltage against time. So we can see at 1 second, this is what we call as a step time, right? It rise from 0 to certain amounts of voltage. Alright, so this amount of voltage is 240, which is the maximum value. Alright, and we realize that the input voltage supplied from 1 second to 10 seconds constantly, right? 240 volts. Right, so next is the motor torque, right? So for motor torque, we can see that the rise time is, or the step time is at 1 second. Then but it's not just 1 second, it increase until certain amount of second, right? And then here is the maximum value for the torque, which is 46.93, and then after that it slowly decreased to certain amounts of torque at 10 seconds, right? Or we can say 11.12 for the torque. So after that, the motor speed, right? So this is the waveform of the motor speed against time. Okay, so at 1 second, it rise slowly to 10 seconds, and this is the max value for the RPM. We can see here clearly. This is the maximum, right? So the maximum RPM is 3687, right? And then lastly is the tachometer voltage. Right, so at 1 second it increase, right, to 10 seconds. It's just slow increase. Alright, it's not that rapid, but it's slowly, right, to 10 seconds. And the maximum volt is 239.6 volts, right? So it approximately to 240, which is our input voltage, right? It is a slight difference between the input voltage and the tachometer voltage. Right. So after we have done run the simulation for this part, we need to modify a bit our figure or our block diagram, which is we need to make speed as our input, right? So we have make another block diagram, and this is how it looks like. So we can see this is the input is speed, and then we add another component, which is the tachometer constant, and the value is still the same as the tachometer constant at the end of the system, which is 0.065. Okay, so this is only the changes. Alright, for the speed, we need to vary from range of 400 rpm to 2600 rpm, but in this video I will just show 400 rpm. See, the value is 400 rpm, right? And the rest of the parameter value remain unchanged, right? The simulation time is still 10 seconds. Alright, so let's have a look on the input voltage waveform. Alright, so this is the input voltage against time. Okay, so at 1 second it rise to 26 volts, right here, 26 volt. We have to move the decimal point to read it, right? And like always, the input voltage we supply constantly, right, to 10 seconds. And then this is the input voltage, and then we have a look at the tachometer output or the tachometer voltage, right? So from 1 second it slowly increased to 10 second, and here is the maximum volts, which is the 25.96, right? So approximately to 26, which is our input voltage, right? And then the last one is the speed output, or the speed, this the speed of the motor, right? So from 1 second it slowly increase, and here the maximum speed at 10 second, it's always the maximum speed. Alright, we notice that. And so the maximum speed is 399.4 rpm. Right, this is in rpm, right? So still approximately almost similar like the input speed, which is 400 rpm, the one that we have set. And we also notice that the shape of the curve is similar between the speed output and the tachometer output, right? So we observe many things between the first part and this part, right? Even we have changed the input speed, or we use the voltage adder as the input. The between the input and the output is still almost the same, even just a slight difference, it doesn't matter, right? And the break for both part is 0, so it doesn't affect too much at the system, right? So that's only for my part.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. My name is Akil Shadi bin Azim, and my metric number is DE10104. And in this part of this video, I'll be talking about activity 2, which is we will monitor the speed motor behavior for open loop speed control system. So for the first part is we need to identify our input voltage, and to do so, we need to input our speed 2500 rpm here. And then after we apply that, we will move to our tachometer constant here, and then when we run our simulation, and we can obtain our input voltage here at t10 second here, our input voltage is 162.5 volt. So we can take this value here and we can change it to our input voltage here. Okay, and we can change it 162.5. And after that, we need to delete our tachometer constant, and our input voltage will directly to be connected to our submission junction here. And we set for our break scale at 0, and after that we run the simulation, and we can see the speed output here at t10 second here. Our speed output here is 2496 rpm. So then we increase our break scale here to 9, and then we run our simulation again, and we can see the behavior of speed output here. Now our speed output is 1803 rpm. So finally, for the third one, we increase our break to the maximum, which is 21, and we run our simulation here, and our speed output here is 879. So as we can see from our output graph here, when we increase our break scale here, our speed output will gradually decrease from 2000 rpm to 879. So what we can conclude here, when the break scale increase, our speed of the motor will also decrease. So that's all from me. Thank you.
My name is Amar Safi Bezamzuri Arifin, matrix number AE1900061. And I'll be presenting about simulation for activity 3. First, we arrange the block diagram as we arrange the circuit as plot that were given in the instruction. First, we have input voltage. For the input voltage, we set the initial value and final value 162.5 volt, and for the sample time is 10, which is according to the procedure given in the lab manual. And after that, we set the gain for proportional gain, torque constant, and tachometer constant. For each of the value, we use as the value given in the table for activity 1, which is similar to electrical part and mechanical part. And for brake, we set the initial brake with 0. Now, and for the saturation, we set the upper limit with 240 and the lower limit with 0. Then we run the circuit. So as we can see, this is the motor speed for when the brake is 0, and the speed output, as we can see, this is the graph for speed output like this. And after this, we change the brake with the value that were given in the instruction in activity 3, and then we will get the value for the brake for the motor speed for each value of brake that were given, and it is also the same with the speed output. That's all from activity 3. Thank you.